Welcome to Z. Today, we're venturing into one of the most mind-bending concepts in modern physics, the multiverse theory. Are we just one of many universes? What does this mean for our understanding of reality? The idea of multiple universes has intrigued scientists, philosophers, and dreamers alike. From quantum mechanics to cosmology, the multiverse concept challenges our perceptions of space, time, and existence itself. Join me as we explore the different interpretations of the multiverse, the evidence supporting these theories, and the profound implications they have for our understanding of the cosmos. So, what exactly is the multiverse theory? At its core, the multiverse suggests that our universe is just one of many, possibly infinite, universes that exist parallel to one another. Each of these universes may have different physical laws, constants, and even different dimensions of time and space. The term multiverse encompasses a variety of hypotheses and theories, including the many worlds interpretation of quantum mechanics, cosmic inflation, and string theory. While these ideas originate from different scientific fields, they all point toward the tantalizing possibility that our universe is just one piece of a much larger cosmic puzzle. The multiverse concept invites us to rethink fundamental questions about existence. If there are countless universes, what does that mean for the uniqueness of our own? Are there alternate versions of ourselves, living different lives in these parallel realities? These questions not only stimulate scientific inquiry, but also spark our imagination. One of the most famous formulations of the multiverse theory comes from the many worlds interpretation of quantum mechanics. Proposed by physicist Hugh Everett III in 1957, this interpretation suggests that all possible outcomes of quantum measurements actually occur, but in separate, branching universes. Imagine rolling a die. In a traditional understanding, you observe one outcome, a 6, for instance. However, according to the many worlds interpretation, when the die is rolled, all possible outcomes happen simultaneously in different branches of the universe. In one universe, you rolled a 6. In another, you rolled a 3, and so on. This idea radically alters our understanding of probability and causality. Each decision we make or event that occurs might create a new universe, leading to an infinite number of realities existing alongside our own. While this may sound fantastical, the many worlds interpretation has gained traction among physicists as a way to explain the strange behavior of particles at the quantum level. Another framework supporting the multiverse theory is cosmic inflation, a concept introduced by physicist Alan Guth in the 1980s. Inflation posits that the early universe underwent a rapid expansion, growing exponentially within a fraction of a second after the Big Bang. During this inflationary period, tiny fluctuations in energy density could have led to the formation of bubble universes. In this model, our universe is just one bubble in a vast sea of other bubbles, each representing a different universe with its own set of physical laws and constants. Some bubbles may expand and evolve like our own universe, while others could collapse or take on entirely different forms. The idea of bubble universes suggests that there could be regions of space with conditions so different from ours that they might not even support life as we know it. Evidence for cosmic inflation comes from observations of the cosmic microwave background radiation, the afterglow of the Big Bang. This faint radiation contains tiny fluctuations that suggest the universe underwent rapid expansion. While this does not directly prove the existence of other universes, it provides a compelling framework within which the multiverse theory can exist. Now, let's delve into string theory, a theoretical framework that attempts to reconcile quantum mechanics and general relativity. String theory proposes that the fundamental building blocks of the universe are not point-like particles, but rather tiny, vibrating strings. One intriguing aspect of string theory is the concept of the landscape multiverse. In this framework, the strings can vibrate in different ways, leading to a vast number of possible physical laws and constants. Some estimates suggest that there could be around 10 to the power of 500 different ways to configure these strings, resulting in a staggering number of potential universes. Each configuration would correspond to a different universe with its own unique properties. This landscape of possibilities raises profound questions about the nature of reality. If our universe is just one configuration among many, what determine the specific laws that govern our existence? This leads to the anthropic principle, which suggests that the universe we inhabit must have conditions suitable for life because we are here to observe it. In other words, if there are countless universes, it's not surprising that at least one of them, ours, supports life. The implications of the multiverse theory are staggering. If multiple universes exist, our understanding of reality, causality, and even destiny may need to be reevaluated. The multiverse invites us to contemplate our place in an ever-expanding cosmos filled with possibilities beyond our comprehension. However, the theory is not without its challenges. One of the biggest criticisms is the lack of empirical evidence. How can we test or observe other universes? The scientific method relies on observation and experimentation, but the multiverse theory may not lend itself to such approaches. Some scientists argue that the multiverse theory risks becoming unscientific, as it may not be possible to falsify or verify its claims. Others contend that the search for evidence is ongoing, with advancements in cosmology and quantum physics potentially providing insights in the future. Additionally, the concept of the multiverse raises philosophical questions about free will, determinism, and the nature of existence. If every decision creates a new universe, what does that mean for our sense of agency? Are we merely following predetermined paths, or do we have the power to shape our realities? Beyond the scientific discourse, the multiverse theory has found its way into popular culture and philosophy. From science fiction novels to movies and TV shows, the idea of alternate realities has captivated audiences. Films like Doctor Strange and the Multiverse of Madness and series such as Rick and Morty explore the possibilities of different universes, raising questions about identity and existence. Philosophers have also engaged with the multiverse concept, examining its implications for notions of reality and the self. If countless versions of ourselves exist in parallel universes, how do we define who we are? The multiverse challenges the very fabric of identity and perception, prompting discussions that stretch beyond science into the realm of existential inquiry. In essence, the multiverse theory invites us to confront our deepest questions about life, reality, and the nature of the universe. It encourages us to dream big and explore the unknown, pushing the boundaries of what we consider possible. The multiverse theory opens up a captivating landscape of possibilities that transcends our current understanding of the universe. Whether through the lens of quantum mechanics, cosmic inflation, or string theory, the idea that we might be just one of many universes challenges us to rethink our place in the cosmos. As we continue to explore these theories, we inch closer to unlocking the mysteries of existence and the universe itself. The multiverse, while still largely theoretical, encourages curiosity and inspires the pursuit of knowledge in both science and philosophy. Thank you for joining me on this exploration of the multiverse. Until next time, keep wondering about the cosmos, embrace the mysteries of existence, and never stop asking the big questions.